So the next idea is bringing in differentiation. We haven't done differentiation so far. So let's say you have an object which is moving under a particular function. So you still have, let's say instead of velocity, we are using displacement s and then time on the x-axis. And let's say it is a bit of a trickier curve. Let's do a quartic curve. So that is a degree 4. So we're going to say s is equal to t to the power of 4 minus 32t plus 14. So the first thing that we can figure out, or the first thing that we can do is, we can figure out, find an expression for the velocity. Now if you remember, velocity is the gradient of displacement time graph, and because this is not a straight line, if I want to figure out the gradient, the best thing that, or the best mathematical tool that we can use is differentiation. So remember, we would have done dy over dx, but here we are doing ds over dt. So if you take the differential of this, t to the power of 4, Yakub, what does t to the power of 4 differentiate to? 4t cube, brilliant. Sazul, what does minus 32t differentiate to? Minus 32t, what does it differentiate to? Minus? Minus 32. Said, what should I do with the 14? You don't do. So the differential of any constant term would be 0. So I can say the expression for velocity is 4t cubed minus 32. So if I want to figure out the initial velocity, what do I have to do? T is 0. So I know the expression for velocity is 4t cubed minus 32. So if it has to be initial velocity, I just have to plug in t as 0. That would give me v is equal to minus 32 meter per second. Sorry? At the beginning, you have a negative gradient, right? So you have the negative gradient. So remember, for a displacement time graph, it is the value of the gradient that gives you your velocity, not the intercept. So please be careful with that one. So we know velocity. So v is equal to 4t cubed minus 32. Can I find acceleration from velocity? Because gradient of your velocity time graph would be acceleration. Now, if you have trouble remembering this, I use the dvla thing. So skip the L. So displacement, if you differentiate it, you get velocity. Velocity, if you differentiate it, you get acceleration. L has nothing to do with it. Yeah. I'm pretty sure DVLA you will all remember. L has nothing to do in mechanics, so you can just skip the L. You guys know what the DVLA is, right? Now, if forwards is differentiation, going back would be integration. So if forwards is differentiation, going back would be integration, and that is the entire chapter 11 with that one diagram. So forwards differentiate, backwards integrate, and that's pretty much it. Sorry? D is displacement. Displacement, velocity, acceleration. Right, so if you think about it, I have velocity now. I want to figure out what is acceleration. Yusuf, what would a 4t cube differentiate to?
12t squared.
It would be 12t squared. Jatin, what would be minus 32? It would disappear because a constant term doesn't really have an acceleration. So, if I want to figure out what is the acceleration at, let's say t equals 2 seconds, all I have to do now is plug in t as 2. So that will be a is equal to 12 times 4, which is equal to 48 meter per second squared. So with this diagram, that should kind of sum up everything that we are going to do in this chapter. So remember, DVLA forwards, you differentiate, backwards, we integrate this. Gradient of a velocity time graph is acceleration. Gradient of a displacement time graph, that would be your velocity. So can you have a go at the questions in the booklet?